Hello everyone, welcome to the next class on the distribution function. Today we will discuss about what is the beta distribution and what is the meaning of this distribution is there. Myself Dr. Garg, working in the School of Mathematics, Harper Institute, India. You can contact me either of my email IDs if you feel any doubt. So what is the content of this presentation is there. We will see firstly what is the applications of the beta distribution, what is the beta function and how we can correlate with the distribution. What is the PDF of the first and second kind, what is the transformation rules, and the most important thing, what is the intuition behind the PDFs of the beta distributions, and finally what is the interpretation of the beta parameters and the shapes of the beta distribution. So first of all, what is the applications of the beta distributions? As we know that the beta distribution is one of the continuous probability distribution. All of you also know there are many other continuous probability distributions are there, like we have discussed in the previous classes, like uniform, exponential, normal, gamma distribution, triangular distribution, and many more are there. So beta distribution is one of this continuous probability distribution, and it is widely used in our day-to-day life. For example, if you want to compute the probability that what is the probability to click through the rate of your advertisement. If you put up your advertisement, what is the probability that the people will click on your advertisements? Also, what is the how you can model the probabilities related to the conversion rate of the customer who are actually purchasing on your websites. Also, what is the probability that the people will like your video and then put up a like on this video. For example, if I say I put up this video, so what is the probability that you can put a like on this video is there. Similarly, many more are there. What is the probability that the Modi will be the third terms? What is the probability of the chances of the women for the breast cancer, and many more are there. So in order to understand this, we will see what is the beta distributions are there. So as all of you know that in the mathematics, the integral this beta of mn is defined like this way or this way, that is, one is over the domain 0 to 1, second is from 0 to infinity. So motivation from these two functions, we can define the PDFs as like this way. So if we define the PDF based on this integral, we call as the beta function of the first kind. If we define based on this integral, we will call as the beta distribution of the second kind. And also all of you know how we can compute the beta function, that is nothing but the gamma function of n, gamma function of the m upon m plus n. So clearly says that if you look about this, the beta function of the mn is nothing but my beta function of the n comma n. So both have the same thing. So let's define the first distribution corresponding to this integral. So look at that, the domain of my function is from 0 to 1. So if we define a random variable x over the domain 0, 1 such that this integral divided by beta of mn, that is to make the integral to be 1. So if any of the function f of x which is defined like this way, we call as the beta function of the first kind. And you can see there are the two unknown parameters, one is the m and second is the n. So we usually denote it as x. This means it follows, x follows the beta distribution, 1 represent for the first kind with the parameter m comma n. Similarly, so if you substitute the value of the m and n are positive, so if you substitute m and n 1 here, so what will happen? This part will be my 0, that is x raised power 0 is 1. This part is also be 1. What is the beta function of the 1 comma 1? So that is the gamma function of 1 upon m plus n. So what is that? This is 1 upon 1 into 1 factorial, that is 1 upon 1 is 1. So therefore, whenever m and n is 1, now my function is f of x is 1 over the domain 0, 1. So do you think that this is any of the distribution function like of either the uniform, exponential, normal and so on? Yes, you are true that this is the PDF of the uniform distribution. You can see 1 upon b minus a. This is my b, this is my a, so it will be a 1 upon b minus a. So therefore you can conclude that beta function will reduce to the uniform distribution when m and n are my same and it will be a 1. Also, you can see whenever x follows the beta distribution of the first kind, then what is the 1 minus x? So if you replace x to be the 1 minus x, so what will happen? This will be my beta function of the m comma n. What is that? This will be now 1 minus x raised to power m minus 1. This part is nothing but my x of here. So look at that, that part is my beta function, but here this is my n and m. You can see that. So therefore 1 minus x follows the beta distribution of first kind again, but the parameters are now my n and second is my m. Similarly, we can define the beta function of the second kind based on this formula. You can see the domain is my 0 to infinity. So we can say any of the function, any of the random variable x which are lies from 0 to infinity is said to be the beta function distribution of the second kind, denoted as beta 2 if we define this PDF as here, and it is denoted by x follows beta distribution. Now you can easily transform the beta distribution of second kind into the first kind by using this transformation. That is, if you take, that is a 1 upon 1 plus x as my y, then then what is the value of the x? This is nothing but my here. You can easily find that, it will be 1 upon y minus 1. So you can substitute the value of x in here, you will get the beta distribution of the first kind. So whenever x follows the beta distribution of second kind, then the y which are defined like this way, 1 upon 1 plus x, follows the beta distribution of the first kind. Or you can say the beta distribution of the second kind transformed to the beta distribution of the first kind by using the transformation rule 1 upon 1 plus x. Now why does the PDF of the beta distribution look like say this one? So what is the intuition behind of this? Why the beta distribution is particularly here, and what is the physical significance? So if you think about this part, look at that, this part is my constant which is used only for the normalization parameter. So it means if I ignore this parameter, so what will happen? The remaining part will be is my here. Look at that. Okay, but clearly it is not the PDF. The PDF is only when you divide it by bit. So do you think what is that? The first part, if you think about this, what is that? This is nothing but x raised to power something. What the second part is? This is 1 minus x raised to power something. So do you think that any of the other distribution or any of the other thing which you have learned so far which satisfy these two conditions? Have you think about that? So I can give you a few fraction of second, you can think about that. Yes, absolutely true. You are the accurate one. That is the binomial distribution. Look at that. What is the binomial distribution look like? Say this is here, and look at that, this is a normalization pattern. There's a constant is there. So look at that, something power x or x power, what is the q? What is q is nothing but 1 minus p. So you can see x raised to power something and same 1 minus x raised to power something. So I can say p raised to power x or 1 minus p raised to power n minus x. So what is the meaning of that? This is for the discrete distribution, beta is for my continuous. So therefore you can see the intuition behind the beta distribution will come into the play when you look from the lenses of the beta distribution. So it behave like a binomial distribution, provided you have to think about that x raised to power something and 1 minus x raised to power something. So how it behaves like that? You can see that this is the binomial distribution PMF or the PDF, and this is the beta distribution. Look at that. In this case, what is the x represents that? X here is my 0, 1, 2 and so on, and which is nothing but my number of the success. That is my here. And what is the my P is the probability of the success. That's the meaning of this is. Or you can say x is my random variable. So you can say x is my random variable, start from the 0, 1, 2 and up to n, and p is my parameter. Look at that. In case of the binomial distribution, how many parameters are there? There are always two parameters. One is the n, second is the p. So here p is my parameter, x is my binomial, x is my random variable. On the other hand, if you look about this beta distribution, look at that. What is that? Here, what are my parameters? In the beta distribution, parameters are my m and n. And what is my p is? P is my random variable. Look at that. G of p is a function of the p. That is, p is nothing but my random variable. So that's the difference between the binomial and the beta distribution. So if I sum up them, what is the meaning of that? In the binomial distribution, x is my number of the success, p is my probability of the success in case of beta distribution. On the other hand, also you can say in case of the binomial distribution, probability is a parameter because this is a parameter, while in the beta distribution, probability is my random variable. So you can see this is a slightly difference between the binomial and the beta distribution. Now what is our interpretation of the beta parameters? So you can see this is a beta distribution. How many unknown parameters are there? M and N. And P you must have known, because P is my random variable. So it can be 0, it can be 0.1, it can be something up to the 1. So what is the interpretation of the beta parameters M and N? What is the meaning of that? So look at that. If you understand the meaning of the unknown parameter here, again you can see what is the M. M is nothing but my number of the success. And if you think about N minus N as the number of the failures, so you have to think about N minus 1 is the number of the success, N minus 1 is number of the failure. Do you think any of the other distribution which is similar like here? Again a binomial. You can see what is the binomial is. X is my number of the successes. What is the N minus X is number of the failure. So it means the property of the beta distribution behaves similar to the binomial. So again M minus N you can consider as the number of the success. N minus 1 is the number of the failure, just like N or N minus X in the binomial. Now you can choose M or N since these are the parameters, so you can choose as per your convenience. For example, if I say, if you think that the probability of the success is very high, say 80%, so it's a success, so I can consider M is my 80 and the remaining is my 20. On the other hand, if you think like, say, if I say what is the probability that people will like my this video, so what is the probability that you can like my this video, you can click on this like button. So if I assume that the probability of liking this video is 80%, so I can consider M is my 80, and what is that 20% people will not like this video. They watch the video but they don't click on the like. On the other hand, if I say the people will think about that 80% of the people do not like my this video. So what is the meaning of that? M do not like, so it means this is the failure. So it means N is my 80, M is my 20. So that is, since it's a random variable, so that's why this is you have a prior. So this is the probability of the prior you know have. As the M becomes large, that is a more successful events are there. So if I say if the more like will put up on this video, what is the meaning of that? The probability of the success will be high. So once the probability of the success will be high, it means the bulk of the probability distribution shifted towards the right hand side, because M will increases. On the other hand, if increase in the N means that is a failure. So what is the meaning of that? If the N will increases, then it means the more the failure will be happen. So that is a distribution will be shifted towards the left hand side. However, you can choose the value of the M and N as per your convenience, and if you increase both M and N, then the distribution becomes the narrow. How we can see in the couple of there. So for example, if I say, let's say how likely someone would agree to go on a date with you. So what is the probability that if someone would like to go a date with you? So I assume that there is a 2% or the 20% and 80% are there. So it follows the beta distribution. So I say out of the 10, 2 will go with you and 8 will not go. So what is the meaning of that? M is 2 and 8 is N is, what is the probability that the success rate will be more than 50%? So look at that, you want X is more than 50. So what is that? This is 0.5 to 1. What is the beta of Mn? This is 2,8, x raised to power m minus 1, x raised to power 7 of dx. So once you will integrate this, that's quite easy. How you can find the beta function of this is gamma function of 2, this divided by 2 plus 8. So you can solve this a constant part, so you can integrate them. So once you will integrate, you will get this answer. So this is very low. So it means the success rate of the someone will go the date with you is a very low. That follows the beta distribution. Now that look at the what are the shapes of the beta distribution. There are the many shapes of the beta distribution depending upon the parameters of the M and N. You can see it can be the bell shape. All of you know that what is the bell shape is like. This is the bell shape. Straight line, U shape, increasing, decreasing, and so on. So how you can decide what is the parameters of that? Now, so as you can change the value of the M and N, you can change the shape of their parameters. For example, look at that. If I say M and N both are my greater than 1, then the PDF of your beta distribution, that is this one, Mn x raised to power m minus 1, x raised to power here whatever the value of the mn you can take. For example, if I take beta of 2 8, it means I take n is 2 here in this example. In this example, I can take mn is my 5, here is m is my 8, n is my 2. You can draw the graph of this for varying the value of the x. In this case, you can see the graph will be like a bell shape, but not exactly with the normal one. On the other hand, if you consider either m or n as 1, either at least one of them considered as a 1. Look at that. In this case, I consider m as a 1, n as my 2. You can see m and n both are my 1. In this case, m is my 2, n is my 1. So, and one of the parameter is 1 and other is my 2. So, the graph will be my straight line. Why? You can see what is the value of this is my beta function of the mn. So, x raised to power here. So, if you consider any, say I consider m is 1, n is my 2. So, if you substitute here, this will be 0, that is a 1. This will be my 2 minus 1 is 1. So, that is my beta function of this 1 minus x. So, that's a straight line, that's a decreasing. So, you can see the value are decreasing. If both are considered to be 1, so it means 1 minus 1 0, this is 0, and the function will be my 1, that's a straight line. And if you consider m is 2, n is 1, what will happen? This will be my beta function of the 2 comma 1, x raised to power 1, 1 minus x raised to power 0. So, that is nothing but my x is there upon, so that's an increasing function. So, you can see this green line is my increasing. So, that is corresponding to the increasing, this is the constant, and this is for the decreasing. So, this, that is a straight line will happen when either one of them is value is 1 and any of the other values is my 2. On the other hand, now look at that, this value is used when m and n both are greater than 1. This value is used when at least one of them will be 2. And the third case is when m and n both are less than 1. And also we know that m and n positive. So, it means whenever m lies between 0 to 1, n lies between 0 to 1, then the shape of the beta distribution is my U shape. You can see that. This is a graph corresponding to the 0.5, 0.5. This is corresponding to 0.8, 0.2 and so on. So, you can see this, the U shape is there. Also, if you want to increase the value of the mn, so you can see this is a comparison of the beta distribution with respect to the normal. So, you can see m and n are my small. So, if you take m plus n is my large and m and n are approximately equal, then the beta distribution behave like a normal distribution. You can see this is not the normal distribution. Why? Because m and n are not large. Look at that, m plus n is 5, which is not a large number. So, you can see that if it is not large, then it will not behave like a normal. You can see m plus n as compared to this is a large, but it is not exactly normal. You can see here as a 10 plus 15 and here is exactly, but look at the peak point, they are not normal. And you can see here is the exactly normal are there. You can see m is my 50, that's a large, n is my 70, m plus n is large, and m and n are approximately same. So, it means whenever the beta distribution will reaches to the normal distribution when m and n are approximately equal and this is a large number. So, whenever this will condition satisfy, beta distribution converges to the normal distribution. Also, what is the intuition behind of this? What is the physical significance of this? What is the meaning of this? What is the meaning of the beta 2, 2? So, look at that. If I say beta function of the 2, 2, that is gamma function of 2, gamma function of 2 and 2 plus 2 is 4. That is 1 factorial upon 3 factorial. I think all of you know that gamma function of the n is n minus 1 factorial if n is my integer. And otherwise, if n is not integer, then you can expand them like in terms of this if n does not belong to the integer. So, you can see what is the 1 factorial is 1, 3 factorial is 6. So, that is a constant value. So, but what is the meaning of this? So, you can see whenever m and n is greater than 1. So, what is the physical meaning of this? So, you can think about that. This is my m, this is my n. So, m minus 1 is my success, n minus 1 is my failure. So, what is the meaning of the 2 and 2? So, what is that? 2 minus 1 is 1. So, it means you get the 1 success. 2 minus 1 is a 1 failure. What is the meaning of that? What is the sense? It means once you are, if you are doing an experiment, you will get the one success, you will get the one failure. So like say if you toss the coin, you will get one success either as a head or one failure of the opposite. So what is the probability of the success in that case? If you are doing the experiment and your outcomes are only 2, the success probability will be half. On the other hand, what is the significance of my beta 1, 1? Why it's a linear? So what is the meaning of the 1, 1? 1 means, look at that, m minus 1, that's a 0 number of the heads, 0 number of the tail. What is the meaning of that? What is the 0 number of the head and 0 number of the tail? What is that? It means you guess the probability of the success should be same throughout the 0, 1. Why? Because there is no head, there is no tail. So what is the meaning of that? The graph will be my straight line. So you can see this graph is my straight line. So that's all about this beta distribution. There are the physical significance and there about their intuition behind this beta distribution. So I hope you can like this video also. So we will see more about the how you can find the mean and variances of the beta distribution. Till then, you can find some another playlist like say distribution function of the channel name Dr. Harish Garg, where you can find the binomial distribution, Poisson distribution, geometric distribution, continuous distribution, many more are there, and with a simple 3-step rule for the explanation. Till then, all you can find this video on my channel link Dr. Harish Garg. Best of luck students, happy learning.